Good morning, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic magnetic field intensity due to straight conductor. So before starting with the discussion, let's recall about the magnetic field intensity. So magnetic field intensity is produced, majorly magnetic field is produced by the external current element. So the intensity of magnetic field is determined by the magnetic field intensity. By making use of Biot-Savart law, we can determine the magnetic field intensity of a straight conductor, circular conductor, and even a solenoid. So, what is the basic for the foundation for this magnetic field intensity? So, engineers need to precisely measure the magnetic field around a current carrying conductor for designing the antenna and for other electromagnetic compatibility. So, the real world applications for this magnetic field are antenna design and optimization, power transmission systems, and electromagnetic interference system. So, what is the core concept behind this magnetic field intensity? So, using this Biot-Savart law, we can determine the magnetic field intensity. The law is given by DH, differential magnetic field intensity, is equal to ideal R by 4 pi R cube. So, ideal cross R, it is a cross product, divided by 4 pi R cube. So, according to this law, the magnetic field intensity is directly proportional to the current element and inversely proportional to the square of distance. So, which means that each infinitesimal current element contributes to the magnetic field intensity. So, I is a current element, I is a current and dl is a length in element vector which totally contribute the current element, and r is a distance and h is a magnetic field intensity. How to visualize this magnetic field geometry? First, we can identify the current element. We can define the differential vector length dl along the conductor path. Second one is that establish the position vector. So, determine r from a current element to the field of point of interest. Third is that we have to apply the cross product dl cross r to find the field direction using the right hand rule. And final one is that we have to integrate the contribution. So sum of all the differential elements has to be done to obtain the magnetic field intensity, which is nothing but we have to apply the integration. Next one is a calculation for a finite straight conductor. We are considering a straight conductor of finite length which carries a current I. The field point P is located at the point which is perpendicular at the distance R from the conductor. So what are all the steps involved in this process? First one is that we have to express the position vectors in cylindrical coordinate system. Second one, we have to apply the Biot-Savart law to current element. Third one is we have to integrate over the conductor length, and finally we have to simplify using the angle substitution. So the equation B is equal to mu naught by 4 pi I by R sine of phi 2 plus sine of phi 1. So what are all the special cases involved over here and what are all the applications involved over here? First thing is that infinite straight conductor, when the conductor extends to infinity, if theta 1 is equal to 0 and theta 2 is equal to 180 degree, then the result for magnetic field intensity is given by H is equal to 1 by 2 pi R. This is most commonly used in the electromagnetic field analysis and the antenna design. Second one is the semi-infinite conductor, which means that for a conductor extending from origin to infinity, the one angle becomes 90 degree, which gives the H as 1 by 4 pi R. This is used for analyzing the fields near the termination and as well as the field points. So, the basic Biot-Savart law enables a calculation of magnetic field from any current distribution through the vector integration of different configurations. And next one is a straight conductor formula. Here we have got H is equal to 1 by 2 pi R. For infinite conductor, for semi-finite conductor, it is 1 by 4 pi R cos of theta 1 minus cos theta 2. So next, what are all the practical applications involved over here? It is very important for antenna design and for power system analysis and electromagnetic interference predictions. So far we have discussed about the magnetic field intensity due to straight conductor. So we have discussed about the fundamental concept behind it, what is magnetic field intensity, flux density, and how the Biot-Savart law is being applied. And next is a calculation process, and we have discussed about the conductor types, finite conductor and infinite conductor. And finally we have discussed about the engineering applications. Thank you.